Hmm.
So this is my explanation for the calculation part. In the calculation, we use the Boyle's law formula that states that P1 V1 equal to P2 V2, which is P1 V1 is pressure initial and volume initial for the air inside the cup before the cup being turned upside down, and the P2 V2 is pressure final and volume final, which is after the cup being upside down. So the pressure that we use is equal to 1 atmosphere, which is 101,325 pascals. So for the volume final, the volume of air in the cup will increase because of when the cup being upside down, a little bit of water will leak out from the cup, and that will make more air go inside the cup. So this will make the pressure inside the cup become lower compared to the pressure out of the cup, because of the amount of pressure is inversely proportional with the amount of volume. Satu V1 V1 equal to P2 V2. So volume 1 kita assume lagi dalam tu, kita assume sebagai 0.3 meter cube, and V2 kita assume sebagai 0.35 meter cube. So in the calculation, pressure 1 equal to 1 atmosphere equal to 101,325 pascals. So 101,325 itu kalikan dengan 0.3 sama dengan P2 kita tak tahu, lepas tu V2 0.35. So P2 equal to stop log 1.8650 Pascal. So sebab itu P2 check then P1. Okay. Assalamualaikum to our lecturer, Dr. Amar bin Abdul Rahman. In this video, I will present about our task on assignment 2, question 2b, that is about understanding and application of fluid mechanics in real life. And we choose Bernoulli principle as our example. Our group have 3 members, that is me, Arif Ami, Muhammad Azrul, and Nur Amir Ashraf. We choose vacuum cleaner as our product for this group project. Part 1. Introduction to the principle of Bernoulli. Bernoulli principle states that an increase in the speed of fluid occurs simultaneously with decrease in static pressure or a decrease in the fluid potential energy. The principle is named after Daniel Bernoulli, who published it in his book Hydrodynamica in 1738. When a non-viscous fluid flows through pipe with a change in cross-section, Bernoulli's equation states that the pressure is lower when the velocity is higher and higher when the pipe extends out and the fluid stagnates. Many people are perplexed when they first encounter this illness. Part 2. Application of vacuum cleaner. For the first step, when the vacuum being turned on, the electric current operates the motor. The motor is attached to the fan, which has angular blades. Second, as the fan blade turns, it will create a high velocity and around the fan will have lower air pressure, so that it will force air inside the bag toward the exhaust port. Step 3. When air particles are driven toward the exhaust port, this will make all the pressure inside the bag of vacuum decrease and lower than the air pressure from surrounding of vacuum cleaner. And lastly, due to the pressure difference, the air from surrounding air will push itself into the vacuum cleaner through the intake port to the vacuum bag and carries all the dust at the floor with it. Part 3. Theory of vacuum cleaner. This is the formula for Bernoulli principle, and it is applied to concept of vacuum cleaner too. Part 4. Conclusion. From the result obtained, we conclude that the Bernoulli's equation is valid for flow as it obeys the equation. As the area decreases at a section velocity increase and the can pressure decrease.